Hello, my name is Mio Shosh, and today I'll be presenting to you Lab 2 Charge Tape Revisited. Hello, my name is Mio Shosh, and today I'll be presenting to you Lab 2 Charge Tape Revisited. Our purpose of our lab was to continue analyzing the data from Lab 1 by developing a more advanced computational model to calculate the E force on the charge tape. Instead of using a point charge, we modeled the tape as a line of charges to reflect the actual distribution of the charge along the tape. Our main results preview was that the single piece of tape was calculated to have an electric force of 1.92 e to the negative 8 coulombs. This value is about twice the charge magnitude calculated using the point charge model in Lab 1. Moving on, our models and assumptions. Our experimental model was the same experimental setup we used in our first lab. The computational model was coded in WebVPython, and the tape was represented as a line of charges as opposed to a point charge. The assumptions was that air resistance is neglected, charge is distributed evenly around the tape, and both pieces will have the same amount of charge after the procedure, and finally the two pieces of tape will act as point charges. Here's the introduction for fundamental physics principles. We used Coulomb's law, which allowed us to calculate the force between the two charges, and each piece of tape was observed as a point charge in Lab 1. The gravitational force, Fg equals mgr, allowed us to calculate the gravitational force on a given mass. Newton's second law was also used, with P equaling momentum and T equals time. And then E field of the distributed charge, we had E net equals sum of E initial. Here's a description of our model right here. The two charge tapes are separated by distance d, and they're represented as point charges in Lab 1, but spread apart along a line in Lab 2. The experimental setup and procedure. The system was the upper suspended tape and the surroundings were the lower suspended tape and everything around it. This was the initial procedure. The procedure continued. We held the tape above the books as we described in Lab 1, and we observed interactions with different objects. Collected data from Lab 1 was all the constants here, and then we had our charge tape, which was calculated as 1.05 e to the negative 8 coulombs when represented as a point charge. Computational model, now we have our constants laid out here, and then a walkthrough of our code. This function was used to calculate electric field. This was to create a line of charge as opposed to a point charge in Lab 1. We create the two tapes as collections of point charges with this, and then electric field and force calculations were calculated starting here, and then we iterated through each charge on top tape to calculate the electric field and forces, and then eventually use this to visualize it in the next slide, and then output our results. Here's the output. We can see the magnitude of our electric force was here, gravitational force, and then magnitude of charge on one piece of tape. We see the E force pointing up. We see tape B here as well as tape A on the bottom, and gravitational force acting downwards. The similarities and differences between the data and model predictions were that the computational model and real-life experiences still showed some differences. In reality, the gravitational force and electric force acting on the charge tape are not perfectly balanced, and other forces are also at play. Modeling the tape as small point charges rather than a single charge made the results more accurate, and the sources of error were outlined below, such as different charges on each piece of tape. Finally, the discussion. If we had modeled each of our tapes as single point charges, like in the lab, we calculated the estimated value of the charges we get. The experimental data calculations in Lab 1 were this number as discussed before, and in Lab 2, our glow script code outputted 1.92 e to the negative 8th, which is almost about double. These estimates differ because the first model oversimplifies what's happening in the experiment, as if there are charges concentrated on one point, and Lab 2 is closer to real-life values. Finally, the conclusion was that breaking the tape into smaller point charges provided a more accurate way to calculate the charges, and dividing it evenly into smaller, more infinitesimal pieces provided a stronger accuracy on the electric field calculations. But however, the point charge models still do not perfectly capture the real charge distribution found on larger objects. Thank you.